Good afternoon, ladies and gentlemen. Thank you for joining us. My name is John Rath. I'm Director of Operations for NY-GEO, which means I do whatever the board wants me to do, and Christine as well. Thanks for coming. Today we're going to talk about feasibility tools. So we've got two great speakers. I'll give a very quick introduction and we'll get going. I mostly want to make sure that you understand about the credits if you're here for credits. I will be in the very back at the end of the session, and I'll have a printed sheet with some names on it if you pre-registered. I gotta have your signature on that form. If you didn't pre-register, I still gotta have your signature, but it'll be on a different form. If that makes sense, I'll explain it when it gets done. Bottom line is, don't leave here if you want credits without getting a signature on at least one piece of paper. Today, we're going to talk about feasibility studies, approaches, and tools. And as I said, we've got some really good speakers. Leading off will be Scott Thompson, who's a regional sales manager for Climate Master, about 12 years in the industry. And maybe even more interestingly, he is the winner of an award at a film festival in Italy as the best villain in the movie. So you want to know more, you got to ask him during the questions. Should be an interesting performance. And not to be outdone, Tim Ashmore works as a client service leader for CDM Smith. 15 years experience in engineering and construction, and he does a lot of work with a variety of network systems as well as individual buildings. So with that, will you please give a warm welcome to these two speakers.
All right. Afternoon, everyone. Appreciate your time, appreciate the opportunity. Said I'm Scott Thompson. We got 2 slides for that. I guess we don't need to go through this. Yep, 12 years in the industry, about half of that spent in the water source heat pump geothermal world. So I'm going to talk to you about the feasibility side of the GeoLoop design, right? Very important aspect of this. You can see this is sort of a cradle to grave flow chart for the design of a geothermal system, right? Feasibility is a big chunk of it, very important. I'm going to focus on the financial side of it. I'm a sales guy, so that's the most important part for me. Feasibility tools, we're going to talk about 3 of them. First one is it's a system operating and lifecycle cost tool. It's called the BEST software. Second one will be an initial cost one. That's Climate Master Geoeconomics Calculator. And then the third one, which is a hybrid comparison tool. So you can check out how a hybrid geothermal system looks to, say, a traditional geothermal or a traditional condenser water system. Right, so getting into it. The BEST software, that's the Building Efficiency System tool. It's developed by the Hydronic Industry Alliance. It's an interactive, this is according to them, interactive commercial building HVAC system efficiency comparison application, right? Bit of a mouthful. Basically what this thing does, you're able to analyze real-world HVAC options, right, to pinpoint the best system that meets the budgetary and performance requirements for your specific project. Okay, it's very easy to use. It's completely customizable. It's got over 30 preloaded HVAC systems in it, right? So you can pull those in on their own, use the default information in there, or you can go in and customize all that stuff yourself. So it's very easy to use, but also very powerful and customizable tool. You can download here at this, what do you call those, QR codes, or the website's down at the bottom here. This is what the program looks like when you get into it. You can pick location, building size, right? You can do energy cost. You can input your own, or you can use defaults. And then down at the bottom there, you can see you can use default heat loss and gain, right? Your loads. This is not a load count tool, right? This is not train trace. But it is a great tool for comparing different systems for a specific building, right? So you can go in, you can use the defaults, or you can add your own stuff in there if you do have a load count done already. So you can, it's got all 50 states and different locations preloaded in there for real, accurate, reliable weather data. You can do customizable building design to get it, make sure it's as representative of your actual project as it can be. You can do length, width, perimeter, height, number of floors, floor height, all that good stuff. Like I said, the energy cost will pop up as default. You can put your own in there if you want, get a little closer. I know New York City's a little different than, say, Albany, probably. But I Googled it for New York, and it did come pretty close. So I'm not just throwing bad data at you here. It's reliable financial estimates based on real-world energy costs. So what it's going to do is it's going to give you 4 systems. You can pick up to 4 in one report. It's going to give you this energy model for it, right, based on what you've input and the defaults for the system. It's going to give you total annual energy costs, and it's not just the building that's customizable. It's these systems themselves too, right? So you can use the defaults. This is a closed-loop geothermal water source heat pump system. It will populate all this stuff for you and give you a typical system, or you can go in there and pick your own, right? You can use the default efficiencies, or you can put in specific for specific equipment that you're looking at. You can model, say, a single pipe versus a 2-pipe. You can do constant flow pumping versus variable flow pumping. You can include a DOAS for outdoor air. You can include domestic hot water, both on and off the geothermal system. This really is a very powerful tool, and that's all the customizable options for just a water source heat pump system, right? Just a geothermal system. It's got all the other ones in there, VAV, rooftop, VRF, all good stuff. This is just a snapshot of the reports that it can kick out. It can give you total life cycle cost, total system energy cost, right? Calculates both monthly and annual energy consumption and costs. So again, this is just a couple things that the report will kick out for you. This particular one is a closed-loop GEO water source, a traditional boiler tower water source. System 3 is the chilled and hot water VAV, and System 4 is VRF, right? Hopefully it's no surprise to anyone in the room here that GEO is the lowest total life cycle cost system between the 4 and the total annual energy consumption leader, right? Here's an example of what it'll give you for the energy consumption and cost, and give you monthly or annual. This is a very useful slide here. You can see for the VAV, just the fossil fuel cost for the boiler is more than the total annual energy cost for the geothermal system, right? So key takeaways for this one: it's a very powerful tool, but again, it's very easy to use. It's got that wizard-style configuration. You can get in less than 15 minutes, kick out a report for 4 different system comparisons. All that stuff I mentioned, total life cycle cost, total energy consumption. It's got 30 preloaded HVAC technologies in there. The best part about this is the price is right. It's absolutely free to download. No upfront cost, no licensing cost. Big thanks to the Hydronic Industry Alliance for that, getting that out to the public for anyone to use. Second tool we're going to look at is the Geoeconomics Calculator by Climate Master. That first one will give you all this, like I said, total life cycle cost, system cost, building efficiency. This is going to address that upfront cost of the geothermal system, right? Everybody's heard it 100 times. Geo costs too much up front. A few years ago, that might be true. It's just not anymore, right? Somebody mentioned this morning that geothermal went almost overnight from the most expensive system to the VE option all of a sudden. So this was developed by Climate Master and ComfortWorks. We're based out of Oklahoma City. ComfortWorks is a local contractor down there. This does the upfront economics of geothermal versus a traditional system. Make sure you take advantage of all the available IRA incentives, right? If you're not familiar with the IRA, I hope everybody is in this room at this point. If you're not tired of hearing about it by the end of this week, we're probably not doing our jobs, but I'm going to go through it one time real quick anyway for you. It's passed in 2022. It reclassified geothermal as a renewable energy source, just like solar or wind, right? So it's not product or brand specific. It's not technology specific. If you can get it on that geothermal loop, you can take advantage of the IRA with it. Basically, it's an up to 50% federal tax rebate, 30% just for using the geothermal, an additional 10% for domestic content, and an additional 10% for energy community credits. It's going to run through 2034, so it's not going away anytime soon. We don't have to worry about that. It did open up the direct pay option, which is fantastic. Previously, only taxable entities could really take advantage of it. Now, pretty much everyone but a federal government building, right? So non-taxable entities are now capable of doing the IRA, so that's schools, nonprofits, churches, state and local government buildings. Huge opportunity for all these customers. It also increased 179D to up to $5 per square foot. It's important to note that is on top of the IRA rebates, along with any other local or municipal rebates. This is what the tool looks like. It's an Excel spreadsheet. This was an office building we did in Oklahoma a while back. Give you an example of how this works. You fill out this top part. It's all building information. The most important thing to take note of here is the business type, because again, while the non-taxable entities can take advantage of the IRA, it can't take advantage of the accelerated depreciation, right? So this will calculate the 5-year MACRs. What that does is that pulls that full 30 whatever years of depreciation, pulls it into the first 6, right? Gets you that accelerated depreciation, another huge opportunity. Again, that is on top of the IRA. So this tool will really give you a full breadth understanding of how advantageous GEO can be financially, even on the front end cost, right? Which again is not what traditionally people think. So once you have that filled out, you're going to put in this middle section here. That's your cost of the GEO versus the conventional cost question. Oh, I was just about to say that. So that's something you have to put in there, right? Now, that I agree, that's not always an easy piece of information to get, but I just showed you a fantastic tool, the Building Efficiency System tool, that will actually kick out initial system costs for you based on building size, location, all that stuff. So you can get those estimates from that first tool. Yes, sir? Yes. Sorry? And on this particular case, it's 0 year. You're taking all my thunder away from me. I want to get to that. It'll calculate that for you. So if you see down here in the bottom right, it'll give you a simple payback years. In this particular instance, on this project, it was 0 year payback, infinite rate of return. So yeah, give me a sec. Once you got the cost in there, you've got this next section here, right? This is where you pick what credits you qualify for. On this particular one, we did 30% for the GEO, 10% domestic content if you buy domestic manufactured goods, and 10% for the energy community credits. If you have any questions about those specifically, feel free to come find me after this. I don't have a lot of details on it. It's a whole lot of information for a short presentation. You can include things like energy inflation costs, right? 5% a year, electricity goes up. We're calculating out 10 years, so we want to give you a realistic expectation for 10 years from now. And then the savings per square foot for going with GEO. Of course, it's a cheaper, more efficient system anyway, so you want to account for that in the total calculation down here. So this is what we're really looking for down here, right? It's all going to calculate for you once you got all that information input, so don't worry about doing any of that. We've taken care of that. It's going to break it out. You can check what each individual thing you get it from, but really what we're focused on down here is your GEO net cash flow, right? That first column gives you your annual for that particular year, and the second column gives you your cumulative. So this is what you're asking about. Once you take advantage of the IRA, in this example, it was an additional $500,000 to go GEO compared to the rooftop VAV, but we saved $860,000 with the IRA. Right? We had 75 cents a square foot saving because it's a more efficient, lower maintenance cost system, which gives us obviously a 0 year payback. You had a $787,000 year one positive cash flow by switching to GEO, right? So it was $800,000 cheaper to go GEO than to go the less efficient, shorter lifespan equipment, right? Does that help you out? So if you want an example, and I was hoping that's what you're getting at, if you want an example of what it looks like without the IRA, this was a Catholic Charities we did, pre-IRA, down in Oklahoma City again, right? So you qualified for 0 of the IRA rebates. You did get a local utility rebate, and you do of course, still account for the additional savings from efficiency and maintenance, right? But, excuse me, it was about 30% more expensive to go with the geothermal system, right? An additional $260,000, it looks like, or just I'm not good at math, whatever. A couple $100,000, 30% more. $0 for the IRA rebate. You were $170,000 negative in year one. So in this particular instance, just straight GEO comparison, it's about a 6 year payback, right? Which is about a 15% rate of return. It's really not bad. but that is what people always say is why they don't do GEO, right? Costs too much up front. It's a 6-year payback. That's too long. We really want 2 or 3 years ideally on these types of capital investments. That's fine. It's not the case anymore, right? This is pre-IRA, post-IRA. Again, because of the direct pay option, it's a charity, doesn't pay taxes, but can still take advantage of it. The exact same numbers, the exact same system, but we're able to take advantage of all 50% of the IRA. We get a $422,000 rebate from the IRA, gives us a $250,000 year one positive cash flow. Again, we're right back to that 0-year payback, that infinite rate of return. So it took what was legitimately an upfront large expense to go GEO. It now makes it the no-brainer option, right? It's higher efficiency, it's longer lasting, it's easier maintenance, it's more environmentally friendly, and now it's the most financially viable option. So anybody tries to tell you it just costs too much up front, download this this software, run through the numbers with them. It tells a fantastic story. So takeaways of it, take advantage of the incentives. They're out there. It's $700 billion or whatever is earmarked for this stuff. It's not going away. Lasts for 10 years. Non-taxable entities especially can now take advantage of this. Schools have always been a great option for GEO. They've always liked it because they're going to be there a long time. They got all the land. They're going to pay their own bills. Now it's just all the more prettier for them, right? So if there's no message out of this presentation you take with you, GEO is absolutely not, it is no longer the higher upfront cost system, right? It is not only competitive, it is now the lower cost option compared to the traditional systems. We've shown that time and time again. We've gone through quite a few of these calculations with our tool, and I have never seen it come back anything but 0-year payback, infinite rate of return. It's as good as it gets, right? So we're also here to help. I know it can be daunting if you don't have those numbers. Contact Climaster directly. We'd love to help you, or contact one of our local manufacturers reps. They're all pretty well familiar with this at this point. Finally, we've got this hybrid software I wanted to show you. It's the hybrid ground-coupled heat pump system. Lets you compare hybrid systems versus traditional systems. If you say, Scott, that's fantastic. I love that it's cheap, but it's still just a little too much money up front, or I'm worried about the taxes, whatever. There are even alternatives beyond that, right? So if you're not familiar with what a hybrid ground loop system is, it's from a loop perspective, it's basically identical to a traditional heat pump system, but you're able to reduce the size of the loop itself, and then you supplement with an additional piece of equipment, either a boiler or a tower, right? So heating dominant environment. You're going to size the loop to cover 100% of your cooling load, and then you will have an extra small boiler to bridge that gap between what the loop will cover and what your peak heating load is, right? Does that all make sense to everyone? Of course, vice versa for a cooling dominant, you'll have a cooling tower instead of a boiler. So these are fantastic. Reduces the upfront cost of the system because it's significantly reduced well field. You still get to take advantage of all the benefits of a geothermal system, and most importantly, as long as you are more than 50% of the annual heating load is covered by the geothermal loop, you can still take advantage of the IRA, right? Amazingly enough, the IRA will even pay for 50% of that gas boiler. Feels a little counterintuitive because the whole point of it is decarbonization, but hey, that's the way it's written. Why not take advantage of it, right? Yeah, I didn't write it. I just like to talk about it. So this tool, it's great. This is kind of a more narrow application than the other two. It's not as powerful, not as useful, but I do want everybody to know it's out there because hybrids are fantastic. Even if you just have a small space for your field and can't get the full field in there, do a hybrid, right? You can still do GEO. There's always an option, or almost always an option, right? So the pros is it's still very customizable. You can do customized loop inputs on it as well. That's fantastic. It'll kick out a 20-year simulation, life cycle cost, energy consumption for hybrid, for traditional GEO or for traditional condenser water systems. That's also one of the cons. So that's the only thing you can compare. You cannot do VAV, you can't do fan coil, you can't do VRF like the other system can. Excuse me. And one of the biggest limitations here is it only has ARI data loaded for 3 cities. It looks like there's a way that you go in, put your own in for specific cities. I couldn't personally figure it out, but y'all are very smart engineers, so I bet you guys can. So if you don't live in St. Louis, Phoenix, or Atlanta, it's not an extremely powerful tool. But Again, if you just want a general comparison, what's it look like? Maybe your, maybe your weather's similar to one of those cities. It should work for you. This is what the kick-out looks like. The report gives you life cycle cost, individual equipment cost, operating cost, all that stuff. If you want to compare what can I possibly save on top of my GEO by going to a hybrid GEO, right? Quiz time. I sat on a couple of these earlier, and people were asking like hard questions. I think I softballed a lot of these to you guys. So, true or false? Geothermal heat pump systems have the lowest total life cycle cost. That's good. Good job, guys. Up to what % of the installed cost of the geothermal system can qualify for the IRA tax rebates? Sweet. Yeah, these are easy. Yeah, you guys are really smart. Maybe both. Thanks, buddy. Does an organization need to pay taxes to take advantage of the IRA tax incentives? They do not for the direct pay program. It's fantastic. Anybody but a federal government building pretty much can qualify. What percentage of annual heat load must be from the geothermal system for a hybrid to qualify for the IRA incentives? 50% again. That wasn't even a hard one. You already said it. Good job, guys. So that's pretty much it, but I want to leave you this one thing. This is my favorite quote from the US EPA. Geo-exchange systems are the most energy efficient, environmentally clean, and cost-effective space conditioning system available today. I think we all knew that, but we gotta love hearing our own government say it too, right? So that's it for me. Any questions? Yes, sir. So that is, as I understand it, the 50% of the heating load, which does make sense because they want you to decarb, right? So if you're already electric cooling, we want you to make sure that the heating is on the GEO loop. I can't confirm that because I've never spoken to the people that write it, but that's my assumption on it, if that helps. But yes, it's 50% of the heating load. Used to be 75, but then they dropped it to 50. Yes, no, I understand. I agree with you, but no, it's heating, yeah. Heating, just heating. Correct.
Or is it energy or power?
Say it again?
Is it, when you say load, is it energy or power? Is it a design load or is it the energy used all winter?
I believe design. Yeah,
Design.
no, yeah, design. Yeah, do you mean like the actual consumption?
When you say
Like-
load, 50%
Yeah.
of the load, what are you referring to?
The design heating load, yeah.
Design in BTUs per hour.
Yes.
Okay, thanks.
Nope. Great. Tim Ashmore, everyone. Thank you, guys. Thanks.
Bear with me a moment. I find myself always following very charming speakers, so that's my cross to bear, I guess. It helps. I said that to him ahead of time. All right. I also have 2 title slides. My name is Tim Ashmore. I work for CDM Smith. CDM Smith is a full suite design engineer and consultant. We're also an EPC. We've worked on a number of network geothermal systems, and we also perform design work primarily on a variety of standalone buildings, mostly in the development space. So learning objectives today, we want to talk a little bit about the elements of a quality feasibility study. What's the difference between doing a standalone building and a network? And then what are some of the tools that we would use to perform this work? I will say that this is going to be a little bit more on the technical feasibility side. So how do we get ourselves some of the data that we might use as inputs to the tools that Scott was just talking to, which really focus more around like doing the financial pro forma and seeing how geothermal impacts your project. So first, I just want to, I think we all know this, but let's remind ourselves, like, where does a feasibility take place in the scheme of a design process, right? We're working through the fells, front-end loading. So initially, you're going to do some feasibility, project-wide. Let's assume that for our purposes today that we're really talking about feasibility for the mechanical system. We're talking about doing a feasibility alternatives analysis for a geothermal design, right? So base case is going to be probably some type of combustible fuel, natural gas, maybe an air source heat pump. And in a lot of cases, we're seeing, of course, because of IRA, because of local incentives, utility incentives, gosh, maybe we should look at some of this geothermal stuff I keep hearing about. I was just in another session where we were talking about, market awareness is a big deal, and I think that particularly on the owner side, there's still a lack of awareness on what your options are to move toward geothermal, and if you've heard about it, you might have only heard that it's highest first cost, which obviously that paradigm is shifting. So as we work ourselves through the FEL process here, you're really building, each subsequent phase builds on what was accomplished in the previous phase. Ultimately, you're culminating in some kind of installation, but right on the front end, you need to understand, technically, can it work? And yes, technically, anything can work with enough time and money. We can go to the moon, we've done it. But is it going to work within the confines of my pro forma? Is it going to financially pencil out? That's where some of those other tools are going to be important. And does it work for my schedule? Is the permitting going to work, right? So you're identifying things that could kind of make the project go left or go right, depending on what all it is that's influencing your project decisions. And that's incredibly unique to each building owner. So first of all, why is the owner doing the project? A lot of times it's to make money. Sometimes there's legal implications, or sometimes you're being compliant to a law that's compelling you to do a thermal energy network, which may sound familiar. But knowing kind of the context that you're in, why your owner is doing the work, really important. How's geothermal fit into the project, right? Is the project going to go forward even without geothermal or not? Like, is it critical to happen? Is it part of some kind of sustainability pledge they've made to investors? Is there a limitation on gas to reach a certain area that you're developing in? So each of these could have different outcomes depending on your findings for what your project is. You should know, kind of as you're getting into this with the owner, what are going to be the 2 or 3 things that are going to make or break the system. We've seen permitting pathways as a major challenge. We've seen drilling proximate to other infrastructure. Can you get, that's another permit, but can you get that permitted? Can we get a driller out there in enough time to stay on track for the rest of the project? Because I've got other systems I've got to get up that are going to be reliant on yours. So these are the sorts of things we need to start evaluating right here in this FEL 1 feasibility phase. And then finally, what endpoint do you want to leave off at so that you're creating a smooth transition into the early design process? And there's no right answer to this, right? The only right answer really is, are you ending at a point that the owner wants you to end at? In other words, you could do a really skinny feasibility approach because you really just need to validate the concept. You need to look at a little geology, understand if you've got groundwater, talk to the permitting agencies, and maybe that's it. Maybe you do a little bit of planning to say, okay, here's where my loop would go. Have I done a test fit in the bore field? We'll talk about, a few of those elements. But I think here is just, knowing where you want to end. If you had to keep taking the project forward, that's, at CDM, a question that we asked ourselves is, if we're going to carry it forward, what's the final deliverable that's going to be valuable to us and what's going to be valuable to the owner? So a few things that we're going to look at nearly every time we're doing a feasibility study. So we want to look at the geology and the hydrogeology, what's the drilling conditions going to be. When we go do engage with a driller, we want to be able to do that in an educated manner. This is also an area where we might also start the permitting discussion, is kind of once we've done this environmental evaluation, we're going to go out and start talking to them about, hey, here's what the project concept is, what's the local permitting pathway, and typically you find out really useful information that helps you start to build out your schedule. Then we're going to get into establishing your permitting pathway and schedule itself, perform an initial test fit. So this is fancy words to put dots on a piece of paper and say, does it fit in the allotted area I have for my bore field? Because you got to initially kind of start to stress test your area. You might be below a building footprint, urban area. You might be on top of a mountain. We're literally working on a project for a ski resort at their peak lodge. So understanding kind of what my topography is going to be and what my allowable space is going to be and what kind of spacing I think I need to leave the driller. We're looking at that right out of the gate. First thing, can we do this? Then we've got the building energy model itself. And on development projects, we often see maybe 4 to 5 or 3 to 5 building energy models. So in a lot of cases, the mechanical designer will run everything. and they'll do the geothermal evaluation and do the feasibility themselves. We've actually been a geothermal SME on a number of projects working under the mechanical engineer. The architect might have its own model. So anyway, a couple of these models get developed, but when you're designing the bore field itself, you want to have your own building energy model so that you're either as aggressive or as conservative as your company really wants you to be around that. And then you're sizing that bore field on the basis of what your model is and whatever guarantees you might have to put up thereafter. So at that point, then, you really need to look at kind of the drill or not to drill question. So some clients want to do this right up front. Let's get it out of the way. I've got budget for it. Others look at it as, gosh, do I really have to spend between $50,000 and $100,000, or maybe it's a little less depending on the circumstances. But in any case, it becomes sort of a sizable amount of capital in a feasibility phase where you're just sort of validating the concept. So a lot of times we'll put that off until we get into an early design phase. I've also seen projects where you let that go a little bit longer into design, and then you validate when the design or when the drilling actually starts and you've got somebody mobilized. It's a little bit more precarious. There's more risk sharing there. So once you've got some thermal conductivity, now you can really establish a preliminary budget. You have a really good idea of how many boreholes you're going to be putting in, and you can start to stay, based on the number of bores and what we think production is going to be, what the schedule is going to be. This is a good time to start engaging with the driller market if you haven't already. Certainly you have if you've drilled a test well, but if you haven't, it's a good opportunity to say, hey, I've got a project this big. We think groundwater's around here. This is approximately the geology that we're going to be in. Here's where we are geographically, and you can start to get some thumbs up quotes. I encourage everybody at this super early stage to have something like a plus 100 contingency factor on what you're estimating. There's just a lot of unknown unknowns at FEL 1, okay? So we really don't know everything we're going to get into, and once you get a test well, it starts to remove some of that out of there. But very early on, I'm a fan of plus 100 in terms of contingency, maybe minus 5. You don't see a lot of projects go under the initial budget, so I like to get people prepared for that. And then perform some initial cost-benefit analysis, right? So talking about some of the tools that Scott highlighted, you can also do life cycle cost analysis as an alternative. So these are elements you're going to be looking at, really, whether or not you're in a network scenario or whether you're in a standalone building scenario. I'm going to say, if you're going to do a network, you're going to look at thermal conductivity, you need to drill a test well. There's more at stake here. So then there's another slew of elements that you add on once you start looking at doing a network. You're looking at off-takers, as I often think of them, right? Your end user customers are off-takers and stakeholders, right? Those are kind of two different things. Sometimes your off-takers are stakeholders, sometimes they're not, but you got to talk to your community, commercial buildings, permitting agencies, but there's a more complex stakeholder proposition that you have to navigate. Then you've got the off-take potential, as I mentioned. Those are really your customers. Do you have enough people signed up on your system? Can you go ahead and start designing around them? This is a really important part in feasibility. Now you're also, if you're in a network scenario, let's say 9 times out of 10, you're doing a retrofit. I should have said out of the gate, we really have the quad chart of you can do a greenfield new development project, you could do a development retrofit, you could do a network retrofit, or you could do a network greenfield, right? So you've got these different options. Oftentimes, a network geothermal system is going to be a retrofit, so you're looking at the conversion complexity across your entire area. So, that could vary from building to building, and that's going to certainly vary just depending on sort of what the nature of that owner is. So then you've got to start looking for utility and infrastructure conflicts. This is something you're probably also checking really in the standalone building category, especially if you're in a place like Metro New York. If you're not, then maybe there's, it's a little less obvious. You're going to want to look at your environmental conditions, and then you're going to need some kind of energy center. And so do you have space to put in a pump house that's either going to house things like an electric boiler, glycol feeder, air separator, pumps. That can go in somebody's existing building, that can go on another piece of property, but typically now you're having to consider acquiring more land. So these are considerations to just have in front of you and laid out for feasibility. At the end of the day, a good feasibility study is trying to start to turn over these stones that are unknown unknowns and make them known, even if they're not going to be answered at that time. Because ultimately, in a network scenario, we're trying to get to a project that looks something like this. I think we've seen this slide in this room already. And of course, a project that's going in now. But we did an extensive amount of feasibility on the Framingham geothermal project, which of course is now in commissioning phase and moving forward. For those who haven't seen this site, it's three primary bore, it's one main bore field there at the north side of the page, and then two satellite recharge bore fields to the east and west. The loop itself took some figuring. It looks intuitive how it sits on the page now, but we were really starting with that primary bore field to the north, and we could have gone north, west, east. You know, we had options, and ultimately we landed on this, in part because of the stakeholders and because of the customers themselves. Yep. I'm sorry?
How does this climate change affects those elements?
It's primarily going to be through your energy modeling, because that's where you're starting to look at your normal energy days on a forward-looking basis. Well, it's on a backward-looking basis is where the data comes from. And you could factor in what you think that's going to be, although I'm not sure there's any actual standard for doing that. I will say that from a feasibility perspective, geothermal systems are inherently resilient because they're buried pipe. They don't have anything combusting that's being delivered in from anywhere else. If the electric system's down, the electric system's down. You know, at some point you are doing a load check, particularly in a network scenario where you're gonna be adding a lot of electric load to an area. So that's something that you've got to evaluate. But I don't think in feasibility we're doing a whole lot of resilience evaluation related to climate change other than considering the weather conditions. That is in part, though, why in the early concept development phase we have a discussion about redundancy and electric boilers, which would basically say that, hey, can we help supplement the heat in the loop such that on very cold days there is not an issue getting hot air out of the system? Yeah. What about hydrogeology? I'm sorry.
Can you repeat the
Sure. The question is, how do you think about hydrogeology as it relates to climate change? I have to say that for me, that's something that's sort of in progress for us. Like, we certainly have a practice area that's looking specifically at how climate change impacts all of our designs across our portfolio. I certainly acknowledge that the groundwater levels will change and evolve as a result of climate change. Ultimately, that really is only an acute issue during drilling, right? So if groundwater rises or decreases, that may impact the energy transfer around the system, but we really won't know that until the system's been in operation for some period of time. Okay, so back to kind of looking at the networks and trying to advance this process. So I know that there's some utilities in the room today. There's certainly a number of utilities at the conference, and this is an area where CDM Smith's done quite a bit of work. So I think that when you're starting off on a pilot project, finding your starting point is often sort of the hardest part, is saying like, okay, well, what's my site gonna be? And that's why there is this feasibility process of looking at a number of different candidate sites and sort of having your checklist of what makes a quality site and what's gonna make a site really difficult. One of the things I like to talk about with utilities right now is the fact that we can make a lot of different projects work, but you don't wanna take a site that you're gonna have to work hard to get to work and make that your pilot. There's a philosophy that you could do it that way and save your low-hanging fruit to the end. I'm more in the mode of like, let's keep it simple in the early processes. Let's get everybody, educated around what's going to be difficult, because God knows we're going to have plenty of challenges as we go through these. Simple systems create more knowns. Okay, so theme arising around unknown unknowns and trying to avoid those. If you're at a utility, you also want to start thinking about resource management. Who are going to be my internal resources to be on my team? Having sort of a multidiscipline group or a multivariate group that all brings a different perspective. We've seen to just facilitate decision-making throughout the process. You also want to consider, who you're going to work with from an SME or consultant and subject matter expert perspective. Once you start dialing insights, you're doing a more step-down, graduated level of your feasibility evaluation. We just went through those elements. You're educating both internally and externally, because there's a whole group of folks inside of the utility who might say, why are we doing this project? And I think that there's an ongoing need to talk about the benefits of geothermal, while also acknowledging that the transition is going to be a challenge. Of course, then there's the education in the community itself. And finally, you want to connect with a number of stakeholders as much as you can. So, a couple of quick tools. You're going to want to use something like Train Trace, and you can pick any, building energy modeling software. I just happen to pick one. But getting a really strong building energy model, this kind of becomes the basis for the entire project that you're going to do. These systems themselves, whether you're talking about a standalone building or a network system, the model is ultimately what I think, the design effectiveness is going to boil down to. So the strength of your model is what the whole house gets built on. And then, of course, you're going to run some kind of GLD model, which is right here. So you're going to want to run some kind of GLD model, understand what your drift is going to be, understand your bore count. Is the depth appropriate? Do we need more bores, fewer? And then once we start looking at network systems, we've developed something we call the decision analysis tool. It's a weighted scorecard, effectively, but we took the time to sit down and think through all of the different buckets that you want to evaluate. And this is certainly an eye chart, particularly for those of you in the back. I did want to highlight a few areas just to look at how we kind of zoom into different technical areas and create this weighting. Before I do that, what I just want to highlight here is, as we go, this is not just a tool for checking through your evaluation and doing scoring. It's a tool for alignment with your owner. Okay, so I'm just going to repeat that. It's a tool for alignment with your owner. It is so easy to think that we're hearing the same thing from one another, and then go a month later and turns out, oh no, this really important thing was like getting rid of gas on a certain street, let's say. Well, if that wasn't ranked appropriately in the decision and analysis tool up front, then it might not have the proper scoring, and the sites that have that feature may not bubble up to the top. So this ultimately is a tool to help consulting engineers or whoever your SME is align with the owner, let the owner provide a lot of input into how it wants to see what the features of its system and what's going to be important are. And then certainly on the engineering side, we've got certain elements that we're going to kind of anchor in and say, this is really important to us. Okay, so having strong thermal conductivity might be important to us because we're on really limited bore space. But let's take a look at a couple of those. So in the geology category, we're looking at depth to bedrock, the drilling conditions, the groundwater producing formations, and what's the drillability of the overburden itself. These are all going to get scored. I'm going to go back. So those get scored to roll up to the total score for what that area looks like, right? So that's sort of how the tool works. Oop. So we're going to look at the right-of-way itself and how accessible it is. Are there overhead wires? Is it difficult to get in and out of the bore field itself? Is the bore field on a slope? Like, that would be a problem. Is there a concentration of utilities in the system? And again, overhead, equally problematic to buried in a lot of cases. You're going to want to check to see, like, are there water tunnels in the area? Are there subway tunnels in the area? So particularly in urban areas, these are things we need to pay a lot of attention to. And we're looking at, are the buildings adjoined or separated? And that in part has to do with looking at the conversions themselves and getting the connection lines into each of the buildings. So we've got building loads that we need to look at. So are you going to need additional land area to cover all the loads that you've got? And what's your total load size? That gets to project economics. A 500-ton system costs more than a 300-ton system. Environmental impacts. So when I'm doing a feasibility study for a standalone building, 9 times out of 10, I'm going to assume that they've already done their due diligence on any environmental impacts. When we're doing this in the utility circumstance, I think it's really important that we look at proximity to wetlands. What are the different jurisdictions? We're probably not on a Superfund site. Those are sort of easy to find and eliminate, but are you on a listed site at the state level? Has there been any remediation there? Because if you're a utility and you start digging up someone else's material, I have to imagine that someone else is gonna say, well, you're the generator now, not me. And the only way I'm gonna build this system is if you get rid of all that material. It's not always a ton, but it can be the difference between the project being a good site and maybe the project going to a different site. So that starts to wrap me up, or that does wrap me up, which means I've got to run you guys through the quiz just like everybody else. So these questions don't really lend themselves to group answers. I'll let everybody read through those a little bit. And I guess the one piece I want to, or the one question I would want is, you know, does anyone have a sense from this of what materials are going to best support the final decision makers as they go through their process? Cost? What was the other one? Yep. I think the answer is whatever makes sense for them. Ultimately, they're the owner, and whatever decisions are like gonna impact, you know, their ability to make this project happen or not, that's really where I want to get everybody aligned around is like fit for purpose, scale yourself to what your owner needs, and move accordingly through that process. With that, I'm happy to take any other questions.
Questions? Okay, great job, gentlemen. Appreciate you being here, taking the time. Anybody that wants credits, please go to the back of the room to my right.